Good morning. Today's class is about electromagnetism. Previous class we saw about magnetism, how to make magnets. Now it's easy to destroy magnet, you know the methods and all, you can read it from the textbook. I'm just explaining only the main concepts that you need to know, or the topics that you will usually get confused or not sure of, all right? Now, electromagnetism, if you ask what is it, all of you might say electricity and magnetism combined together. Yes, the name gives you a hint, but what actually it is and how do we put it into real life use, what is the advantage of electromagnetism, all that we'll see in a couple of lessons. All right, now here what I have drawn, the red mark is showing an electrical connection with a power supply. This power supply is a DC power supply, and this blue color, actually that represents a card that's kept horizontal so that the wire passes through a hole in the card. Now this arrangement is to identify or to demonstrate that there is a magnetism or magnetic effect that exists around a wire when it is carrying a current. All right. Now here what I'm going to do is introduce one key or a switch. Right. That symbol stands for a switch, and also I'm going to place some, or say two, compass needles. Right. What are compass needles? They are used to indicate the direction of a magnetic field. Now say initially, if say that direction is north, when the switch is open, which means there is no current flowing through, both of these compasses will point to the Earth's magnetic north. Now what is observed is when you close this, you see that there is a deflection in these two, or if you place more of compass needles, there are deflections in this. So naturally the deflections indicate what? There is some magnetic effect or magnetic force that is existing around the wire. So when you turn it off or when you release the switch, you will notice that the compass needles point in the same direction as that of the Earth's magnetic field. So this is a proof for you to demonstrate, or for you to really look, and believe that there is magnetic field existing around a current carrying conductor. Okay, that's a basic principle of it. Now, from your examination point of view, what type of questions would arise from this? As usual, they might ask you in which direction is the magnetic field created, because magnet, we all know that it includes direction. So there is a particular direction that the magnetic field will be created around the wire. Now since I said here DC supply, I can also swap the connection. For example, see, if it was deflecting to the right for this connection, if I switch it, you will notice that it moves in the opposite direction. So the direction of the current is what determines the direction of the magnetic field that is created around it. I hope you have got that clear. The direction of the current flow in the conductor will determine in which direction the magnetic field will be created. Now, in the previous session when you're making a magnet, I told you there are 4 rules. The right hand grip rule, we'll be using it in 2 places. This is the second place that we'll be using it to identify the direction of current flow, magnetic field. How is that? We'll see. Now, I'm just erasing this. Now what happens here is when the current here, it is flowing from plus to minus. So it's going down into the paper and it comes like this, right? Now, when you're using the right hand grip rule here, the thumb indicates the direction of the current flow, right? So this should align with the direction of the current flow, and the 4 fingers will indicate the direction of the magnetic field, right? Here one more point for you to note is that the field that is created around the wire will be circular. Okay, we'll have concentric circles. I'll explain that when I'm drawing it on this. It'll be easy to understand. So here, as I said, the thumb will indicate the direction of the current flow, and the curling of the 4 fingers will indicate the direction of the magnetic field. So it's simple. It's going down. So you're pointing it like this. The 4 fingers are curling in a clockwise direction, right? If you notice, it's in the clockwise direction field. So here, if you notice, so clockwise is what the direction of the field will be created. So how will the magnet or the magnetic needle get aligned? You will notice that it will be forming a circle. So here you notice it will be aligned this way, and here it will be this way, right? So you have the direction, as I said, clockwise, and the compass needle will align itself so that it completes a circle. Right? Now, if you want to fill in the entire magnetic field on the card, if you're placing at different points, and if you're connecting it, and if you're trying to trace the complete pattern, finally you will end up with a series of consecutive circles with this as a center point. Okay. Now here, if you notice, I have increased the distance between the circles. This is very important when you are constructing the magnetic field. This also will be noted, and you have to be accurate in these note down these small details. What do they represent? The distance between the magnetic field will represent the strength of the field, right? Keep that point in mind. The strength of the magnetic field will be determined by the distance between the magnetic lines. So here, the closer the lines are, the stronger the field is. Okay, so definitely closer to the current carrying wire, the field is going to be stronger. As you move away from the wire, you will notice that the field becomes weaker. So the distance becomes bigger and bigger as you move away from it, indicating that the strength of the magnetic field is getting weaker. Alright, so this is about the magnetic field that is created around a single wire that is carrying current. Alright, now if they give you in a card and ask you to complete the magnetic field, you have to indicate the direction of the field as well. So how do we do that? Now for this, you need to know the direction of the current flow. Imagine the current is going into the board or into the paper that you are drawing. Then the thumb should be aligned with that direction, right? So you'll be placing the thumb in that direction of the current flow, and the four fingers are curled this way. So here you get the clockwise direction to be the direction of the magnetic field. Alright, I hope this is clear. Go through it once more. And this is very important. This is what you have to remember in terms of your board examinations. Right hand thumb rule. This is the second place that you are using. Current flow, magnetic field direction. Alright, see you in another video.